Here's a practice problem. I can tell you that you can read it. You can see if you can solve this on your own. You should get 0.36 meters or 36 centimeters is how far this arrow will drop if you solve this problem. So if you want to pause it and see if you can go through it and get 0.36, you go right ahead. Or if you want to pause it, obviously, at any point as I'm going through it and see if you can solve the rest of it yourself, that would be fabulous. So the question reads, an arrow is fired horizontally at a speed of 75 meters per second. How far will it drop vertically on its way to a target that is 20 meters away? So let's draw a diagram of this, see if we can understand what's going on. You have an arrow, and it travels this horizontal distance of 20 meters. And it hits a target, presumably. Here's 20 meters. And if you aimed the arrow, let's say you aimed it right at this space here, it wouldn't hit in that location because obviously the Earth is going to accelerate this arrow and it's going to hit some distance away. It's going to drop some distance. So it's actually going to hit somewhere over here. And the question is asking you, well, how much is this arrow going to drop? As it travels this 20 meters to the target, how far is it going to drop? And how far is going to be a displacement, and since it's vertical, we'll call it delta y. So again, what am I showing here? That you're pointing the arrow directly at this spot, directly across from it, but it's not going to hit there because gravity is going to accelerate it downward. So the question is, where's it going to hit? So what do we know about this arrow? We know that it's traveling at 75, that's a terrible arrow, it's traveling at 75 meters per second horizontally. It has no vertical velocity initially, and then it goes 20 meters. So let's list what we know about this arrow, and then we'll see if we can find a way to solve this problem. So first, let me separate my variables into what's going on along the horizontal and what's going on along the vertical. These two aspects of the arrow's motion are independent of one another. So the fact that it's traveling horizontally has nothing to do with how fast gravity is accelerating it. And the fact that gravity is accelerating this thing downward has nothing to do with the fact that along the horizontal, it's moving at a constant velocity. They are independent. So again, I put this little CV here to remind me that it's at a constant velocity along the horizontal. Why? Because there's no force along the horizontal. We know that in order for there to be an acceleration, there has to be a force. No force, no acceleration. We know acceleration is defined as any change in velocity. So velocity won't change unless there is a force to accelerate this arrow along the horizontal, and there isn't. In a free fall problem, in a projectile motion problem, we neglect air resistance. We neglect resistive forces. So along the horizontal, it's at a constant velocity. What does this little FF mean here? I put this here to remind myself that it's in free fall along the vertical. What do I know about free fall? I know that it's always downward, that acceleration is always downward, and it's equal to g, which is a constant, which is 9.8 meters per second every second. Why is it in free fall vertically? Why is it accelerating? Because there's a force on it, and that force is exerted by the Earth on the arrow's mass. So, and that force is called weight, and forces cause accelerations. So there's a downward force on it, there's a downward acceleration on the arrow. And acceleration means its velocity is changing. Its initial velocity in the y direction is 0. It's fired horizontally. So this question, this free fall aspect of this question, how far did it drop, is just like asking if I started the arrow from rest over here and I just let it go and I let it fall for some certain amount of time, how far would it drop? It has nothing to do with the fact that it's moving horizontally too. Remember, the Earth really doesn't care if you're moving horizontally. It's still going to accelerate you at the same rate, except in the cartoons maybe. And I know that my unknown is delta y. I want to calculate that. What do I know in my x direction? I know that the velocity is 75 meters per second. And I know that the displacement is 20 meters. Why am I putting this as delta x? Because it is a horizontal displacement. This is horizontal, just like the x-axis on a graph. And so this displacement here is delta x. This velocity is horizontal, and so this velocity is only the x velocity. I'm not writing initial x velocity or final x velocity. It is at a constant velocity. It goes at this velocity during the whole event. So how do I figure this out? How do I solve this question? I want to know displacement in the y direction. All I know is acceleration and initial velocity, and there is no equation that will let me find displacement if all I know is acceleration and initial velocity. Look at your equations that you have. None of them will let you do that. But if I find time, then I'm in business. Then I can solve this problem. So time, remember, is the same for x and the same for y. This event starts when the arrow leaves the bow and it ends when the arrow hits the target. And during that time, it drops some distance, and it travels some distance horizontally. And the time it takes to travel this horizontal distance of 20 meters is exactly the time it takes to drop whatever vertical distance it drops. Time is the same for in the x and the y direction. So if I can calculate time, I can go back and I can solve for delta y. Do I know enough here to find time? I do. Remember, this is at a constant velocity. So let me find time here. This is the equation that I'm using since it's at a constant velocity. A lot of you are still screwing up isolating this variable out of this equation. I wish you would stop. If you want to solve for time, my first step is going to be, I'll show you both steps. To get time out of the denominator, I'm going to multiply both sides by time. I get delta t over delta t, which is 1. Right? Like 5 over 5 is 1, and 10 over 10 is 1, and a million over a million is 1. T over t is 1. So I end up with 1 times delta x, and I don't have to write the 1. And whatever I did to this side, I multiplied this side by delta t, so I had to do the same here. So I end up with delta t times v is delta x. And I want to know what t is, so I'm going to divide both sides by v. And I end up with delta t is delta x over v. I'm going to substitute. I was given delta x is 20 meters. I was given v is whatever, 75 meters per second. And when I solve for this, I get 0.27 seconds. What is this 0.27 seconds? It means that for an object traveling at a constant velocity of 75 meters per second, it will take 2.7 seconds for it to go 20 meters. That's all I figured out. So we figured that out months ago. We solved problems like this months ago. But now that I know that this whole event lasted 0.27 seconds, now I turn to this free fall part of it, and I say, well, for an arrow that starts at rest and is accelerating downward at a rate of g, how far will it fall in 0.27 seconds? And every object at or near Earth's surface, every projectile is going to fall the same distance. It wouldn't matter if this was an arrow or a Cadillac. Our delta y would be the same. So I need an equation with a acceleration, initial velocity, displacement, and time in it. And that is the equation that we always use. So here we're going to find delta y. Delta y is v naught t plus 1/2 at squared. Initial velocity in the y direction is 0. And I can say 1/2 gt squared if I want to be consistent. Delta y is 1/2, I'll write g this time just to screw you up, 1/2 gt squared. Now I substitute 1/2. I know g is 9.8 meters per second every second, and time is 0.27. And I'm going to square that. And another thing that you guys do kind of often is, in this equation in particular, you just kind of stop, you get rid of that little square there. You can't. So make sure you carry it through your problem. Just go a little slowly and you'll avoid careless mistakes like that, hopefully. When you do the math, you get 0.36 meters. So this arrow is going to drop 36 centimeters, which is about 1/3 of a meter. So you would have to adjust your aim to hit your target.